So what we're going to do here is go through the process of installing MC4 connectors onto solar panels. So what I've got here is I've got a brand new 100 watt Thunderbolt solar panel. What I've done, you can see I have stripped these wires back. I cut off the SAE connector about 4 inches, and I'll keep this for something. Who knows, I'll use it for something. But I cut that off, and I have stripped the wires back, and I've stripped them back about 1/4 of an inch or so. So I purchased this kit. In this kit, it came with 12 male-female pairs of the MC4 connectors. Came with the pliers for crimping them, and it came with the tools for tightening everything up. So basically there are two styles, or a male-female of the plugs. Here's the male, you can see, and here's the female, and they snap together. There's a nice little weatherproof O-ring seal here. But important thing to remember, from the panels, the male plug goes on your positive or red wire. The female goes on your negative or black wire. The positive male plug, here's the inserts here. You can see one's bigger than the other. One slides inside the other. So the male plug actually takes the bigger female connector inside of it. And the female plug takes the smaller male connector. If that's not confusing enough. But it's relatively simple. So what we're going to do, I've got the wire. We're going to start with the male, which is the bigger or female connector. Male plastic, female metal. We're going to set this aside for now. Get our wire, get it stripped. We're going to lay this guy right inside like so. So I'm going to take my pliers. We're going to open them up. And I'm going to slide this in here. Hopefully you can see what we've got going on. And just lightly catch it. We're going to take our wire. We're going to slide that wire inside there. And I'm going to squeeze these all the way down. And they're ratcheting. Then we're going to release. Then I'm going to take this over and I'm going to do the same thing, but in the smallest crimp down here, just because of the wire size. Right here, and we're going to crimp it one more time, like so. And that's really all there is to it. So it's crimped, it's on there, it's not letting go. So you've crimped the female larger insert onto the red wire. So we're going to unscrew this. We're going to slip our cap over the back of the wire like so. And then this piece is going to pull out. And what you want to notice is this little silicone rubber seal. It actually slides into the fitting. So we're going to take this, we're going to slide it over like so. And we're going to take this and slip it into the male fitting, and you're going to hear a click, hopefully. There it is. It's locked in. Hopefully you can see it in there. We're going to slide the little rubber seal and the plastic grommet into the fitting. Slide up the end cap. You're going to run it in by hand, and it's tight. So at this point, it comes with these two little plastic tools. Slip this guy over here. Slip this guy over here, and we're just going to tighten it, and it's actually going to slip over the splines, and that's the click you'll hear, but we'll just tighten it till it slips 3 times. There it is. All right, so now we have 3 of these panels series wired. Positive of this to the negative, positive of this to the negative, and then this positive and that negative together through this little cable. I have not hooked it up yet, but I've got my multimeter here with the probe stuck in the end of my extension. You can see we're sitting at 63.1 open volts, or basically 20 volts a panel. So I'm getting ready to plug it in, and we'll see what we're getting for amperage now. All right, so we now have the 3 series solar panels plugged into the charge controller here. And again, the battery bank was full, so I had to turn on, we'll go over there just to check that out. I had to turn on the hot plate. You can see the lights on, and she's cranking out heat. And I had to turn on the inverter so I could draw the batteries down, because as soon as I plugged this in, the batteries were full, and the amperage was down around 7 amps or so. So I knew, I knew that our batteries were full and the charge controller was ramping the amperage down. So we had to put a draw on it. So here we are. Let's take a look. Coming in from the solar panels, 48 volts. So they're not quite outputting full voltage, but of course, when we measured them with nothing connected to them, that's the open line voltage. But yeah, 47, 48 volts. There's 48.4, depending on the sun hitting them. So that's definitely series. 3 panels in series, 3 20-volt panels or so in series. So now we'll go take a look at the amperage. We're charging at 19.4, 19.5 amps. We're charging very, very well. And again, this tiny little cable. And the reason we can run this cable is because the voltage is in series. The voltage is way high, but the amperage remains the same. So as far as this cable is concerned, it's seeing the amperage from only one panel. If we were to parallel wire these, positive to positive to positive, negative to negative to negative, we would only see about 18 to 20 volts, but our amperage would be added together, so you could potentially get 7, 14, 21 amps coming through this cable, and this would not be near big enough. It would get very hot and melt. Well, what you're looking at here is $102 worth of wire. This is 10 gauge, 5 foot of black, 5 foot of red with MC4 connectors. These are just basically extensions. It's got a male and a female on the red and a male and a female on the black. And then we've got 2 parallel connectors, 2 into 1, same over here, 2 into 1, so that we can parallel 2 series banks into one set of cables. And then we've got our one set of extension cables, 50 foot of red, 50 foot of black. Just these 2 alone were $75. And then with the 5 foot extension and the splitters, it came out to about $102. So once you start paralleling solar panels, things get expensive quick. And because we're paralleling, we're doubling the amperage now. We have to go bigger wire. So something I'll do is down on this end, I will remove this old SAE connector from our charge controller, and I will install much bigger, heavier wires with the MC4 connectors on it to accept my new cables. So we're pretty well going to retire the SAE cables for good. I've got to go pick up 1 more solar panel, so we'll have a total of 4 100-watt solar panels, and I'll probably do that tomorrow. And we'll get this all hooked up and test it. So here is a look at the cable clamps that I just designed. This will hold our new 10 gauge wire to take some of the stress and weight off of where the wire enters into the charge controller. So there'll be a set kind of mounted on the side by the charge controller, and then another set that'll guide those wires around the side to the back of the charge cart. So anyhow, this is it. This is the little design I just whipped up real quick in Tinkercad. And we'll get to printing these out. So this is a hook that I designed, drew up in Tinkercad. And you can see the thin little side there. It's going to slip over the edge of our power cart. And it's kind of hard to tell because the print head's in the way. But that's just a big old hook, basically, that I can spool my cables around. So my 50 foot of extension cable will be, you know, stored neatly on the back side of the power cart. So on the bottom of the charge controller, we have replaced what used to be the SAE input and plug with much bigger 8 gauge cables. And you can see we've got MC4 connectors on there, which is nice. Standard solar connectors. And right here are the cable clamps that we 3D printed. One here and one here. And the whole purpose of that was because now that we've got bigger, heavier cables, and we'll get into it, extension, that's going to put more stress where these cables go into the bottom of the charge controller. And I didn't want this circuit board in here where these terminals clamp the wires to be pulled on. So now with this here, you can grab these wires. You can see I'm pushing and pulling the entire cart, which is a couple 100 pounds, and it's not putting any stress on these terminals in here. And that was the whole idea of these cable clamps. They work very well. So then we come around the side here, and you can see we've got our extension set up with the little hook that we were 3D printing. It fits beautifully, drops right on here. Very, very nice. And it's a place to hang all of the cords and cables out of the way. Man, we are doing great now. Look at that. 27.3 amps. We are charging very well. Let's follow this outside. You can see I've got the 4 panels set up right there. I've kind of jockeyed them around. You can see the shadow of the tree here. That's my plum tree. And originally I had these panels over here and they were partially shaded for about the last half hour. I'm trying to figure out, why am I not getting my amperage? And I realized that the plum tree's casting a shadow on them. So I just took these 2 panels, this one and this one, slid them over into the bright sun. So again, we're connected positive to negative, positive to negative, and then we're taking this positive and this positive together, and this negative and this negative together. So seriesed, and then the 4 of them paralleled into the charge controller at 27 amps. That is a very good charge for 4 panels. I'm very happy with that. You know, this is a 40 amp Renogy charge controller, so I'm 3/4 of capacity on the charge controller right now. So that is awesome. All right, well, here's a quick little Tinkercad drawing that I've did for an enclosure right here that will house the little digital readout here. So I just took some measurements real quick and cranked her out. So here we are, about done with the enclosure that we designed. And 3D printing is a very cool technology. Just being able to make something out of thin air is cool enough. But when you start designing parts and pieces, you'll find all sorts of hobbies that you can supplement with it. There just about isn't a project now around the house that I can't come up with a use for some sort of 3D printed part to design. And really, the sky's the limit. You're, you know, only limited by your imagination. So as you can see, we now have our little 3D printed enclosure mounted below the 20 amp circuit. There is a CT coil, or a current transformer coil, that this uses to measure the current running through your hot wire. So your hot wire to your 20 amp plug, you disconnect it, you run it through that coil, you reconnect it up. And then on the other side of the circuit board for that thing is a 120 hot and neutral wire. You just land on the other terminals on your duplex receptacle, and that's it. So we're going to power this thing up real quick. We'll turn the power on, and you'll see it light up. And there we go. So the very top number, 0.3, is the watts. So depending on where you land this coil is whether or not it reads the draw that this little computer and brain in here and circuit board takes. So that 0.3 watts you're seeing is actually what this thing itself takes to run. But I wanted that included because it's on this circuit as well. And granted, it's a very, very minute amount, but it's on that circuit, and I wanted to include it. Just by where you install that search coil is whether or not it's going to read its own amperage and wattage that it's drawing. So There we go. As you can see, the very top one again, 0.3 is our watts. The next one down is kilowatt hours total usage, and it remembers that. So you turn the power off. I've used this playing around with it. 0.004 kilowatt hours. There's a reset button right here that'll reset the kilowatt hours. The bottom green number here is your amperage draw, and the left number here is your voltage, 117.9. So I'm going to take my multimeter here, and I'm going to stab it, one into that connection, one into this connection, and I don't know if you can see it or not. See that 117.9, 117.8, it's fluctuating back and forth, but it's reading exactly what that little drop meter is. So it appears to be very accurate. So what I'm going to do here, so I've got my drop cord again. I'm going to plug the drop cord in up here at the top, and we'll plug it on, and we'll just see what we get. Let me turn this guy on. So you can see we've got 8.6 watts. Turn it back. Well, I'll leave it on so you can see we've also got a 0.12 amp draw. Turn it back off, and everything goes back down. So this is an LED bulb. It's actually rated at 8 watts. So turn it back on. 8.6, 8.7, back off, down to our 0.3. So it's drawing about 8.3, 8.4 watts. So apparently its rating is pretty accurate. The cool thing about this particular meter is it is good for up to 100 amps, because you're not, unlike like a kilowatt where you're running through it, this is its own little unit that just measures current through your hot wires. So even though it's a tiny little guy, it can handle a large amount of amps, up to 100 amp draw. So we'll plug in. This is our hot plate again. And I'll turn on the hot plate. And let me pull this up a little bit closer so you can see here. There we go. 828 watts, top number watts, at 6.94 amps. So that's the actual 120 draw on the 2000 watt inverter. 828 watts. And that's wide open on that little hot plate. So now we'll turn it off. There we are. And again, 0.2, 0.3 watts and 0.01 amps is the draw of this little unit itself. We'll turn it back on, hot plate back on. There we go. 836, 33, 830 watts at 6.95 amps. One other thing of note, this particular Drock brand little meter, it states right in the instructions not to be used for inverters, not to measure the output of inverters. It says it requires a pure sine wave from mains power. Fortunately enough, this Renogy 2000 watt is a pure sine wave inverter. So as far as that little meter is concerned, it thinks it's, connected to AC mains in your house. If your inverter is not a pure sine wave, do not use this meter. Bad things will happen. You'll let the smoke out of it. So if anyone out there is interested in picking up one of these little voltage, amperage, wattage meters, they're dirt cheap, available on Amazon. This is a Drock brand, D-R-O-K, and I think it's about 18 bucks, something like that. It comes with a little CT coil, everything you need to install it minus the enclosure. So you can cut a hole in whatever you want and pop it in, or print an enclosure, whatever. Anyhow, so we're just about, I think, done with this cart. There's a couple of little things I want to do. I don't know if I'll add any more panels or not. As it is, I have 4, and I'm getting up to 28 amps of charge on my 4 batteries, which is pretty good. The only thing I could improve really, if I were to add a couple more panels, would be my ability to get a higher charge rate in overcast conditions. And we do have more overcast conditions than we do sunny conditions in my particular area, so I may add panels, I may not, but I'm satisfied right now with what it can do. So if you haven't subscribed to the channel, please subscribe, rate, and contact. Thank you for watching, and we'll see you guys on the next one.